Hello everyone, myself Vinay Kumar. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous video, I was explaining about exercise 8.1 questions, which was there in 8th chapter of 9th standard mathematics. So in this particular video, we'll continue with the next questions, which are there in this particular exercise 8.1. So so first question and second question in this particular exercise, third question and fourth question in this particular exercise I have explained in my previous videos. You can refer those videos for those questions. So in this particular video, we'll look into the fifth question, which is there in this particular exercise 8.1. So in fifth question, they have given a particular diagram. So in that you have a parallelogram like this. So let me draw that particular parallelogram. So we have a parallelogram which is named as A, B, C, D. And this particular BD is a diagonal in this particular parallelogram. And they have taken 2 points on this particular BD diagonal, that is, one is Q and the other is P. And this A is connected to Q. So this is point Q. And here A is connected to P. And this Q is also connected to C, and this C is also connected to P. So now we have a quadrilateral forming inside a parallelogram, that is AQPC. So that is AQCP. So now here two important datas they have given, that is, one is ABCD is a parallelogram, the other is this particular DP is equal to BQ. So here we have one data, that is dP is equal to BQ. So here we have dP is equal to BQ, and we have that ABCD is a parallelogram. Based on this, we need to solve few questions in this fifth question. So here you need to prove triangle APD is congruent with triangle CQB. That means basically here we are considering this particular triangle and this particular triangle, which I'll write separately. So we are considering this particular triangle. This is ADP. So this is ADP. So ADP triangle is there, or here they have given APD. So APD is one triangle. And here this particular triangle BQC. So now this particular triangle BQC. So this is B, this is C, this is Q. So now we have to prove that these two triangles are congruent with each other. So in order to prove that these two triangles are congruent with each other, here they have already given DP is equal to BQ. They have already given this. And here they have also mentioned that ABCD is a parallelogram. So in parallelogram, opposite sides will be equal to each other. So that means this and this side will also be equal to each other. So here BD is a traversing line. Here you can see BD acts as traversing line. So this particular angle and this particular angle will be equal to each other. That is, this particular angle and this particular angle are equal to each other. So now here consider triangle APD and triangle CQB. So consider triangle APD and triangle CQB. So in these two triangles, here AD, so here this is AD and BC are equal to each other. So here AD is equal to BC because ABCD is a parallelogram. So they have given ABCD is parallelogram, and in parallelogram opposite sides are equal to each other. That is according to theorem 8.2. So according to theorem 8.2, opposite sides in a parallelogram are equal to each other. So AD is equal to BC. Now here QBC. So QBC will be equal to ADP. So QBC is equal to ADP. This is because AD is parallel to BC. So AD is parallel to BC. So inside bracket, why AD is parallel to BC? Again you can write ABCD is a parallelogram. Since ABCD is a parallelogram, here AD is parallel to BC. Since AD is parallel to BC, QBC is equal to ADP. So here this particular angle QBC is equal to angle ADP. And we know that they have already given BQ is equal to DP. So DP is equal to BQ, which they have already given in the question. So now according to SAS axiom, so therefore according to SAS axiom, here triangle, this particular triangle APD is congruent with triangle CQB. So now these two triangles are congruent with each other. Now we need to prove the second question in the same fifth question. In second question, you have to prove AP is equal to CQ. Here AP is already equal to CQ. Here AP is already equal to CQ, or you can write one particular sentence here for this particular second question. So in this second question, you can write, since triangle APD is congruent with triangle CQB, here automatically AP will be equal to CQ. So automatically AP will be equal to CQ. So now we will look into the third question in the same fifth question. Here in third question, you have to prove triangle AQB is congruent with triangle CPD. That is, here in this particular diagram, this angle, this particular triangle, that is AQB, is congruent with this particular triangle CPD. So let's draw these two triangles. So we have these two triangles like this. So one is ABQ or AQB. So another triangle, that is CPD. Here we know AB will be equal to CD because opposite sides in a parallelogram are equal to each other. And in the question they have already given BQ is equal to PD. Already they have given BQ is equal to PD. And we know that this particular angle and this particular angle will be equal to each other because AB and DC are parallel to each other. Because ABCD is a parallelogram, AB and DC will be parallel to each other. So just we can go on writing this. So here let us consider triangle AQB and triangle CPD. So in these two triangles, AB is equal to DC. So AB is equal to DC. This is because ABCD is a parallelogram, and in a parallelogram, according to theorem 8.2, you can prove this. So theorem 8.2 we have discussed in our previous videos. According to that, opposite sides in a parallelogram are equal to each other. So ABCD is a parallelogram, so AB is equal to DC. Here we can consider ABQ angle and we can consider PDC angle are equal to each other. This is because AB is parallel to DC. So why AB is parallel to DC? Since ABCD is a parallelogram. Since ABCD is a parallelogram, opposite sides will be parallel to each other. So AB is parallel to DC. So that means ABQ is equal to PDC angle. So now BQ is equal to DP. So here BQ is equal to DP. This they have already given in the question. So according to SAS axiom, so therefore according to SAS axiom, here triangle AQB is congruent to triangle CPD. That is according to SAS axiom. So now moving on to the fourth question, here you have to prove AQ is equal to CP. So since triangle AQB is congruent with triangle CPD, therefore AQ is equal to CP. Since these two triangles we have already proved they are congruent with each other, so AQ is equal to CP. In exam, if they ask that AQ is equal, you have to prove AQ is equal to CP. Just if they ask you have to prove AQ is equal to CP, then you have to prove that triangle AQB is congruent with triangle CPD, and then only you can say that AQ is equal to CP. So now we will move into the fifth question. Here the quadrilateral which has formed inside, that is APCQ, you need to prove that this is a parallelogram. So you need to prove that this is a parallelogram. So in order to prove that, you can just prove opposite sides are equal to each other. So in order to prove that opposite sides are equal to each other, we have already proved here AP is equal to CQ. So from second question we had proved that AP is equal to CQ, and from fourth question we had proved that AQ is equal to CP. So that means here opposite sides are equal in a quadrilateral. So opposite sides are equal in a quadrilateral. Since opposite sides are equal in a quadrilateral, therefore APCQ is a parallelogram. So by taking help of second and fourth question, you can prove APCQ is a parallelogram. So in exam, what they can do is they might not ask first, second, third, fourth question. They can straight away ask this particular fifth question, prove that APCQ is a parallelogram in this particular diagram. So then you need to prove that first question, that is triangle APD is congruent with triangle CQB, and then you have to prove AP is equal to CQ. And then you have to prove AQB is congruent with CPD, and then you have to prove AQ is equal to CP. Then you can come to the conclusion that AP is equal to CQ and AQ is equal to CP, that is opposite sides are getting equal to each other, and opposite sides are getting equal to each other means opposite sides will be parallel to each other in a parallelogram, in a quadrilateral. So in a quadrilateral, if opposite sides are getting equal to each other, then opposite sides will be parallel to each other. So that means that forms a parallelogram. So after proving all the four questions, you can come to this particular fifth question. In exam, if they just ask fifth question, then you have to prove all the four questions, and then you have to prove that this particular APCQ is a parallelogram. So now coming into the sixth question, here also they have given one figure. So here they have given a parallelogram. So here also they have given one parallelogram. So this parallelogram is named as ABCD, and here you have a diagonal BD. So in this particular ABCD parallelogram, you have a diagonal BD, and they have given one perpendicular line from BD to vertex A. That is, this angle is equal to 90 degree. This point is named as P, and from vertex C also they have drawn a perpendicular line like this. So here also this is 90 degree. This point is named as Q. So here they have given DPA is equal to CQB is equal to 90 degree. So since AP is a perpendicular line on BD, this angle is also 90 degree, and this particular angle is also 90 degree. So your QC is also perpendicular. So this angle is also 90 degree, and this angle is also 90 degree. So that means DPA is equal to CQB is equal to 90 degree. This is also equal to this particular angle, that is APQ, this particular angle PQC. So APQ, or we can consider this as APB is equal to DQC, which is equal to 90 degree. So that means this particular angle and this particular angle are also equal to 90 degree. Now you need to prove that this particular ABC triangle and this particular DQC triangle are congruent with each other in the first question, in sixth question. So consider, so here we'll consider triangle APB and triangle CQD, that is this particular triangle and this particular triangle. So basically we are considering these two triangles. So basically we are considering these two triangles. The below triangle is APB and the above triangle is CQB. So now we will consider this particular angle, and we will consider this particular angle. Both are equal because both are 90 degree. So ABCD is a parallelogram according to theorem 8.2. Here opposite sides will be equal in a parallelogram. And here if you consider this particular angle and if you consider this particular angle, they will be equal to each other because BC is parallel to AB. So now here according to AAS postulate, so according to AAS theorem, here triangle APB is congruent with triangle CQ. These two triangles are congruent with each other. And in the second question, in the same sixth question, AP is equal to CQ we have to prove. So here AP is equal to CQ. Since these two triangles are congruent with each other, AP is equal to CQ. So now coming into the seventh question, here also they have given one diagram. So here you can draw this particular diagram. So here one data, here they have given a trapezium ABCD, and in this particular trapezium AD is equal to BC and AB is parallel to DC. This data they have given, and they have given one hint where you need to produce this AB and you have to draw a line from C to meet this particular AB line. You have to draw a parallel line which is parallel to DA, and you have to meet at this particular line AB, and this point you can name as E. So now here this particular CE is parallel to this particular AD. So now you can clearly see ADCE becomes a parallelogram. Here since AB is parallel to DC and here AE is also parallel to DC. So construct CE line in such a way that CE is parallel to AD and extend AB to meet at E. So therefore AD is parallel to CE and AE is also parallel to DC. So therefore ADCE becomes a parallelogram. So therefore ADCE is a parallelogram. Since here they have already given AD is equal to BC, and here since this ADCE has become parallelogram, opposite sides should be equal, that is AD will become equal to CE. And in this question already they have given AD is equal to BC. So in this question already they have given AD is equal to BC. So AD is also equal to BC. So that means BC is equal to AD is equal to CE. So now since AD is equal to CE, BC is also equal to CE. So since BC is equal to CE, here you can see BCE is a triangle. So in triangle BCE, BC is equal to CE. So therefore opposite angles of these equal sides will be equal to each other. So in previous chapter we have studied that. So these two angles will be equal to each other. That is CBE will be equal to BEC. So therefore CBE is equal to BEC. This is because according to isosceles triangle property. So or you can write property of isosceles triangle. So now we have got CB is equal to BCE. So these two angles are getting equal to each other. And here they have already given AB is parallel to DC. So since AB is parallel to DC, here since AB is parallel to DC, here AD acts as traversing line. So AD acts as traversing line. Since AD acts as traversing line, here interior angles on the same side of traversing line which is traversing between two parallel lines, they will be, if you take sum of them, that will be equal to 180 degrees. So that means if you add these two angles, it will be equal to 180 degrees. So here AD acts as traversing line. Therefore angle A plus angle D will be equal to 180 degrees. And we know that AE is a straight line. So in this diagram you can see AE is straight line. This AE is straight line. So that means this particular angle, if you are considering, that is angle ABC, that will be equal to that. And if you are considering angle CBE, so ABC plus CBE will be equal to 180 degree because they are linear pairs. So here we know that AE is a straight line. Therefore ABC angle is equal to ABC angle plus CBE angle will be equal to 180 degree. And here we know that AD is equal to 180, A plus D is equal to 180 degree. Angle A plus angle D is equal to 180 degree. So this is because they are linear pairs. So this is because they act as linear pairs, and this we have already proved. So this we have already proved. So now we have A plus D is equal to 180 degree and ABC is plus CB is also equal to 180 degree. In these two equations, you can see 180 degree is equal to 180 degree. So if you consider this as equation 1 and if you consider this as equation 2, RHS are becoming equal in both the equations. So therefore, ABC plus CBE is equal to A plus D. So LHS will also be equal to each other. So ABC plus CBE is equal to angle A plus angle D. And here we'll call this as equation 3. We know that CBE is equal to BEC. We know that CBE is equal to BEC, and we also know that ADCE is a parallelogram. So ADCE is a parallelogram. So therefore D, opposite angles in a parallelogram will be equal to each other. So that is also parallelogram's property. So D is equal to BEC. This is because AD, so this is D, CE. So ADCE is a parallelogram. So since ADC is a parallelogram, D is equal to BEC. So since D is equal to BEC and also CBE is equal to BEC, here therefore here you can consider this as equation 4, this as equation 5. So therefore angle CBE is equal to angle D because of equation 4 and equation 5. Because of equation 4 and 5, we have got CBE is equal to angle D. So now here CBE is getting equal to angle D. So now we'll rewrite this third equation. So in third equation, ABC plus CBE is equal to angle A plus angle D. So now we have proved that CBE is equal to D. So here CB is equal to D. So this you can call as equation 6. So according to equation 6, CBE is equal to angle D. So therefore therefore equation 3 you can rewrite as angle ABC plus D is equal to angle A plus D. So in the place of CBE, I am writing this angle D. So ABC plus D is equal to A plus D. So this D and D you can cancel each other, because if you bring D to LHS, it becomes minus D. So plus D minus D gets cancelled with each other. So therefore ABC is equal to A. So or you can write this as angle B is equal to angle A. So this is what they had asked in first question, in 7th question, and we have proved that. Similarly in second question, you need to prove C is equal to D. Here D is already equal to E. So here D is already equal to E because ADCE is a parallelogram. So in parallelogram, opposite sides are equal to each other. So ADCE is a parallelogram. So D is already equal to E. And we know that here AE is parallel to DC. So here we also know that AE is parallel to DC because ADC is a parallelogram. Since AE is parallel to DC, here in this particular diagram, so in this particular diagram, we have a diagram like this. So here we have point E, and here we have C, and here we have D. This is A and this is B. So here BC acts as traversing line for this particular AE and DC. So that means this particular angle and this particular angle will be equal to each other. And we know that E is already equal to CBE. So we know that AE is parallel to DC. So therefore here EBC will be equal to BCD because they act as alternating angles. And we also know that here this particular angle and this particular angle are equal to each other. So that is CBE is equal to BEC. So this is because of property of isosceles triangle. This is because of property of isosceles triangle. So because opposite sides are getting equal to each other, because here BC is equal to CE, so opposite angles will also be equal to each other. So CBE is equal to BEC. This also we know. CBE is equal to BEC. This also we know. And EBC is equal to BCD. So here EBC is equal to BCD, and here we are also getting CBE is equal to BEC. This is also equal to D, because here we already know that D is equal to E. So here, since ADC is parallelogram, D is already equal to E. So since D is already equal to E, that is BEC will be equal to D, and we also know CBE is equal to BEC. So this you can call as equation 7, and this you can call as equation 8. So now, because we have got CBE is equal to BEC is equal to D, and we have got EBC is equal to BCD. So here this particular CBE I can write as EBC as well. So here this particular CBE I can write EBC, because I'm just writing in this way. I have written like this CBE, so that I can write as EBC. So EBC is equal to BEC, which is equal to D. This also anyway it is similar to equation 8. So this also it is equation 8 only, because in equation 8 I am replacing CBA with EBC. I'm just interchanging the outer points. So C to E and E to C. So EBC is equal to BEC, which is equal to D. And we also know EBC is equal to BCD. So therefore, here you can see LHS are equal to each other. So that means RHS will also be equal to each other. So that is BCD and D will be equal to each other. So therefore, BCD is equal to D, or you can write this as C is equal to D. This is because of equation 7 and 8. So now we have proved these two angles are equal to each other. Now we have to prove triangles are congruent with each other. So in the same trapezium, if you draw diagonals like this, you need to prove that here this is ABCD. So you need to prove a triangle ABC. So that is this particular triangle is congruent with this particular triangle. So this particular triangle ABD have to prove they are congruent with ABC. So here we already know AD is equal to BC, and we also know AB is acting as common side, and here we have also proved that angle A is equal to angle B. So according to SAS axiom, these two triangles will be congruent to each other. Since these two triangles are congruent to each other, this particular BD, so here this AB is common side, so this particular DB will be equal to BC. So consider triangle ABC and triangle BAD. So in these two triangles, here AD is equal to BC. This is already given. This they have already given. And here angle A is equal to angle B. This we have already proved. This we have already proved. And here AB is equal to AB. They act as common side. So they act as common side. So because they are common side, here triangle ABC is congruent with triangle BAD. This is because of SAS axiom. So according to SAS axiom, triangle ABC is congruent with triangle BAD. So coming to the fourth question here, you can straight away write, since triangle ABC is congruent with triangle BAD, since triangle ABC is congruent with triangle BAD, therefore diagonals will be equal to each other. That is AC is equal to BD. So that is what they have asked to prove in this particular question, and we have proved that. This is all there in this particular video. Like this, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.